Hello friends and welcome at my channel. Today I would like to share with you one of the most interesting limits that I presented so far at this channel, and we will use L'Hopital here as well. So let's see if we remember limit of x towards 0 from the right hand side, because only for those cases the bases are defined. X to the power of x was giving us 1. And this is basically one of the reasons why 0 to the power of 0 is giving us 1. Let's go further and let's consider now limit of x towards 0, still from the right hand side, but now x to the power of x. And this is kind of surprising because you would say, well, if 0 to the power of 0 is 1, the result here should be 1 as well. And it's not. Okay, let's see why. So we have a limit x towards 0 from the right hand side. We have e to the power of ln x to the power of x to the power of x. So now pay attention, this x to the power of x is the new power, so we can bring it down using the logarithmical rules. So we have a limit x towards 0 from the right hand side. We have e to the power of, well, x to the power of x times ln of x. This is what we got. And now it's all about this limit. So let's see what's happening if we are having a limit x towards 0 from the right hand side, if we have x to the power of x times ln of x. Is that correct? Think so? Let's see. Yeah, this is correct. So what's happening here? Well, now we're using the so-called factor rule or product rule of the limits, which I wanted to share with you in the last video already. I will remember this time. And if those two limits do exist, we can split it apart. Okay, so let's see. Have a limit x towards 0 from the right hand side, x to the power of x times limit x towards 0 from the right hand side of ln of x. Should we do it? Well, you see, what's the problem here if this limit does not exist? And well, this is, what do we have here? We have here minus infinity, right? So this is minus infinity and this is 1. We proved it. So what is the result here? This is tending to 1 and this is tending to minus infinity. So the result here would be minus infinity, right? I don't need it. It's kind of optional. Okay, so what do we have here? That means that this whole power is approaching minus infinity, and e to the power of minus infinity is of course the same as 1 divided by e to the power of infinity, which would be 0. So the limit here is 0. And this is really surprising, right? So x to the power of x, if x is approaching 0, is 1. And x to the power of x to the power of x is 0. Have we used L'Hopital somewhere? Well, we haven't, but we needed L'Hopital for these purposes, and that's why I say we call it L'Hopital Part 12. Thank you.